Hi, you are listening to Techila Extra Shots. I am Jeevan. The idea of Techila Extra Shots is to really give you an understanding of some tech news items that did not make it to the main bulletin just because it needed a much deeper explanation that cannot be fitted into our 10-minute roundup. I try to piece together information of what some news items really mean and explain it in simple terms to make it clear to even beginners. In this episode of Techila Extra Shots, we take a look at how Google's latest network is learning to route by task for efficient inference. So without further ado, let's get straight to it. Google's latest network is learning to route by task for efficient inference. To understand what this really means, let's take a step back and understand how we currently scale large language models. A common approach is to build a larger model by increasing the depth and width of the network. However, such dense models take an input sequence and pass every token through the full network, activating every layer and parameter, making it computationally expensive. An alternative and increasingly popular approach is to build a sparsely activated model based on a mixture of experts, where each token passed to a network follows a separate subnetwork by skipping some of the model parameters. The choice of how to distribute the input token to each subnetwork or expert is determined by small router networks that are trained together with the rest of the network. While this is an efficient strategy at training time, sending tokens of a long sequence to multiple experts again makes inference computationally expensive because the experts have to be distributed among a large number of accelerators. To combat this issue, Google has now introduced a new method called task level mixture of experts, or TaskMoE, which takes advantage of the quality gains of model scaling while still being efficient to serve by extracting subnetworks from a large multitask model. So essentially, Google's solution is to extract smaller standalone per task subnetworks which are suitable for inference with no loss in model quality and with significantly reduced inference latency. This work has been published in Google's paper named Beyond Distillation. Results show that TaskMoE is 7 times more smaller than other sparsely gated mixture of expert models, where router networks learn to send different tokens and an input to different subnetworks independent of the task. Additionally, it can also be served on a single core of TPU-v3 instead of 64 cores required for other mixture of expert models.